Section 1.9, to estimate the area, perimeter, or circumference of an irregular figure. Perimeter. The perimeter P of a polygon is the sum of the lengths of its sides. Here we have a square. We can find the sum of all the sides or use the formula for perimeter of a square, which is P equals 4S, since all the sides are congruent. For the rectangle, the perimeter equals P equals 2 times B, which is the base, plus 2 times H, which is the height, or again, just find the sum of the sides. The perimeter of a circle is called the circumference. The circumference equals pi times d, which is the diameter. But we know that the diameter is equal to 2r, which r is the radius. The area A of a polygon is the number of square units it encloses. For a square, we have the area equaling A equals 4s squared. For the rectangle, that is the base times the height, and the area of a circle is pi times r squared. For our first example, they want us to find the perimeter and the area. In our figure, we have a single tick on the left of the figure and also on the right. Therefore, that illustrates that these two sides are congruent. And on the top and the bottom, we have a double tick mark. Therefore, we know that these two sides are also congruent. For my perimeter, we have 2 times the base times the height, and then we just substitute 2 times 12 plus 2 times 4 equals 24 plus 8, which is 32 feet. For area, we have the base times the height. We substitute the base, which is 12, times the height, which is 4. That's going to give me 48 feet squared. Recall, for area, it's square units. Using this figure, they would like us to find the perimeter and area. Here, each side has a tick mark illustrated. Therefore, I know that all 4 sides are congruent. They are 10 millimeters. So to find the perimeter, I can use the formula for a square, which is 4 times S, S being the 4 congruent sides. Here, 4 times 10, simplifying, 40 millimeters. I also could find the sum of each side and get the same result. For area, again, using the formula for a square, A equals S squared. This gives me 10 squared. Simplifying, I get 100 millimeter squared. Here they want us to find the perimeter and area of this circle. I'm given a radius, that is a segment from the center of a circle to its endpoint on the circle. A diameter has a segment that has its endpoints on a circle, but it must pass through the center. Here I'm given the radius, and what I'd like to find is the diameter. To do that, I just multiply my radius times 2. 2 times 1/2 will give me 1 centimeter. Now, all I have to do is substitute in my circumference formula, and I get C equals pi times D. We'll approximate pi to be 3.14. My diameter is 1. When I simplify, I get 3.14 centimeters. My area equals pi r squared. Again, the approximation for pi will be 3.14. R is 1/2 squared. 3.14. 1/2 times 1/2 is 1 times 1 is 1. 2 times 2 is 4, which gives me 1/4. And when I simplify and round this to the nearest hundredth, I get 0.79 centimeters squared. Here, we want to find the area in terms of pi. We're going to be given a diameter of 15 centimeters. So if I did want to find the radius, all I'd have to do is take 15 and divide it by 2, which will give me 7.5 centimeters. So my formula for area is equal to pi r squared. I substitute in. Here, they want this in terms of pi, so I'll leave my pi figure as it is. My radius, we already determined, is 7.5 centimeters. squared. Then, when I simplify, I'm going to get 7.5 squared is 56.25 pi centimeters squared. Therefore, I left my solution in terms of pi and did not approximate. Here, they want us to find the perimeter of this figure in the coordinate plane. What we want to do is find the length of each segment by using the distance formula and the endpoints of each segment that are given to us. Let's start out by labeling the endpoints here. Let this be A, B, and C. Let's find the length of segment AB. I'm going to let this point be x sub 2 and y sub 2, and this one be x and y sub 1, and then substitute into my distance formula. Let's begin. -4 minus 4, quantity squared, plus 3 minus a -2, quantity squared. That gives us the square root of a -8 squared is 64, plus 5 squared is 25. So the length of segment AB is the square root of 89. Let's continue by finding the length of segment AC. I'll still let this be x sub 2 and y sub 2, and this one will be x sub 1, y sub 1. Substituting, I'm going to get a -4 minus a -2, quantity squared, plus 3 minus a -2 squared. That's going to give me a -2 plus 2 is a -2 squared, which is 4, plus 5 squared is 25. That's going to give me for segment AC a length of the square root of 29. And in a coordinate plane, if my segment is horizontal or vertical, all I need to do is determine the length is by counting the number of units between the two endpoints. I can use the distance formula, but this is a lot easier. So 1, 2, 3, 4, 5, 6. 6 units long for segment CB. To find the perimeter, I just find the sum of each segment's lengths, which will be the square root of 29 plus the square root of 89 plus 6. Since these are not like terms, I cannot simplify any further. But this is the perimeter of this figure in the coordinate plane. Here, your parents are building a garage with the dimensions of 24 feet by 32 feet, and are going to put a sidewalk 3 feet wide on 3 sides. The 2 shortest sides and 1 along the longest side. Find the perimeter of the entire construction. Let's construct this figure. Here I have a rectangle. Its dimensions are 24 feet and 32 feet. Here I have 32 feet with an additional 3 feet on either side, which would give me 32 plus 6, which is 38 feet. And that would be the same for the other long side, even though there's not a sidewalk going on it, that would still include these 3 feet extensions on either side, so that would still be 38 feet. So the perimeter would be P equals 2 times the base plus 2 times the height, which gives me 2 times 38 plus 2 times 27. And when I simplify, I get 130 feet. Here I'm given an irregular shape, and they want us to find the perimeter and area of the enclosed region. So I need to determine the length of each segment. Here, I know that this entire length is 8 feet long. This takes up 2 feet of it. The remaining length would give me 6 feet. This length would be 6 feet, but since these 2 segments are congruent, this is 2 feet, that would leave this remaining segment 4 feet. Now, all I need to do to find the perimeter is find the sum of the sides. 6 plus 8 plus 4 plus 2 plus 2 plus 6. And when I simplify, 28 feet. Now I need to find the area. Here, what I'm going to do, I'm going to find the area of the enclosed figure. So I'm going to find the area of the total figure and subtract the area of the missing piece. If I assumed that this was complete, then I would have a rectangle that is 6 by 4. Therefore, the area of the rectangle with nothing missing would be 6 times 4. I would subtract out the area of this missing square. That is going to be a base and a height of 2 by 2. And then I would simplify. 24 minus 4 would give me an area of 20 feet squared. On this example, they want me to find the area and perimeter of the shaded region. For the perimeter, the piece that's missing inside my rectangle is not going to affect the perimeter. Therefore, 2 times the base plus 2 times the height equals 2 times the base, which is 20, and 2 times the height, which is 16. Simplifying gives me 40 plus 32, or the perimeter is equal to 72 feet. For the area of the shaded region, the area of the shaded region is the area of the total object, and there we would assume that nothing is missing, minus the area of the square, or the missing piece. Then we just substitute in the values. Area of the total object is base times height, 20 by 16, minus the missing piece, which is a square because of the tick marks, and I know each side of that is 2 feet. So 2 times 2 gives me 320 minus 4 equals 316 feet squared for the area of the shaded region.